Welcome to the start of the new chapter. Talking about chapter 9. This whole chapter 9 is about transformations. We are transforming shapes, we're changing them in one way or another. Now, transformation means you're changing it, as it says. So, whether by a reflection, as this first one, rotations, reflection, no, we do reflections, rotations, dilations, or any combination of that. What's the other one? There's one more. Translations, yeah, translations. Uh, they are all considered transformation because you are changing an original thing to another one. So, for example, this whole thing is on reflection. So, we will have what's called a line of reflection. Now, that line is what we use to flip all points over that line in a given direction. So, for example, if we just say, hey, just I want you to reflect all these points over this line. Oops, that's the right one. We just kind of guesstimate, all right, that's roughly right there. That one probably be roughly about right there. That one's about right there. So it kind of looks the same right there. So that's a line of reflection. Well, there's different types of reflections that you'll see here. Now there's a horizontal and vertical reflection, meaning you're going to reflect over a horizontal line or a vertical line. Now, these lines can exist wherever they tell you. So for example, on this first one, this line right here, the value of this line actually 1, 2, 3, 4, 5, 6. X equals -6. So where x equals -6 is right here. 1, 2, 3, 4, 5, 6. Right there, -6. Well, this whole line is -6. So they tell you, hey, rotate this over the horizontal or the vertical line x equals -6. Well, we're going to do that. That means every single point, and there's three main points in this triangle, there, and there. They're going to be flipped over this line. So we're going to do it in green. So if on this spot, it's 1 unit this way, we're going to go 1 unit the other way. This point right here is 1, 2, 3, 4 units to the left. So we're going to go 4 units to the right on that same horizontal part. 1, 2, 3, 4. And then this line right here is 1, 2, 3, 4 units to the left. So we're going to go 4 units to the right, straight across. 1, 2, 3, 4. Oh, closer to the right there. And then we just cut them. And there we go. We have a reflected version of that exact same triangle. Now let's look at a horizontal one. So this was at 1, 2, 3, 4. So this is at -4. So we're reflecting over the y equals -4 horizontal line. So same thing right here. We're going to reflect straight up and down, up or down. So for example, this point right here is 1, 2, 3, 4, 5, 6 units above the line. So we're going to go 6 units below. 1, 2, 3, 4, 5, 6. This point right here is 1, 2, 3 units below. So we're going to go 3 units above. 1, 2, 3. And same thing right here. It's 1, 2, 3 units below. So we go 3 units up. 1, 2, 3. Boom, boom, and straight across. We have a reflected version of the exact same triangle right there. Now, there are particular types of reflections, what they call it x-axis or y-axis. Works very similar in the sense that it's rotating either horizontally up and down or vertically side to side. An x-axis, even though over here an x equals a number is a vertical line, an x-axis reflection reflects horizontally up and down. So when given just coordinates here, x, y, when you do an x-axis reflection, all you do is just change the value of your y, which kind of makes sense. If I'm taking this point and I'm flipping it down here, my value of the x is the same, but the value of the y, that's what changed. So for example, this coordinate right here is 1, 1, 1, comma 1. If I'm flipping that over the x-axis, that becomes 1, comma -1. This point right here is 1, 2, 3, 4, 5, 6, 6, 1. We reflect that, it gives us 6, -1. 6, -1, so 6, -1. And of course, this third point right here is at 7, 1, 2, 3, 4, 5, 6, 7, 6. We're reflecting that. That gives us what class? Yes, you're right, 7, -6. 1, 2, 3, 4, 5, 6. We connect those, we get the exact same shape reflected over the x-axis. Now, when you do a y-axis reflection, the x changes, so which makes sense. This point, it stays horizontally at the same level, but it changes side to side x-wise, vertically. Well, no. Horizontally it changes, vertically it doesn't. So, for example, this corner right here is at 1, 2, so 2, 1, 2, 3, 4, 5, 6, 2, comma 6. We're reflecting it, so coordinate-wise, the x will become opposite sign, -2, 6. So it should be at 1, 2, 1, 2, 3, 4, 5, 6 right there. This point right there, that's at 1, 2, 3, 4, 5, 5, and then 1, 2, 3, 4, 5, 6, 7, 8. So 5, comma 8. Right? 1, 2, 3, 4, 5. Yeah, 5, 8. Reflecting over the y-axis, so it's going this way. So it becomes -5, comma 8. So -5, 1, 2, 3, 4, 5, and then 8. 1, 2, 3, 4, 5, 6, 7, 8. And so on and so forth. We can do all these, but it's going to take us a little bit longer. So we're not going to do them all. But understand when they tell you, and they'll tell you this on your test, like, hey, I want your reflection over the x-axis. And they're just going to give you numbers. So like, all right, so if it's an x-axis, my y is changing to opposite sign. Now, it's not changing to negative only. So, for example, if you had the coordinates -2, -4, and we do an x-axis reflection, that gives us -2, +4. So it just changed that sign. It just changes it regardless what it is. Same thing over here. If we're given the coordinate -5, 4, and we do a y-axis reflection, we now have +5, 4. It changes the x-axis, the x value. And let's do the last one that you'll see. We have what is the y equals x line. And as you get to algebra 2, this is what we call a parent function of all linear lines. All linear lines are related back to this. They either look like this, or they can move up and down. Doesn't matter. These are all linear lines. This is the parent function for them. But that's a whole different subject. Let's talk about this. So when we're doing reflections over the y equals x line, you just switch those coordinates. These flip over. So what was in the x position becomes y, what was in the y becomes x. So for example, just take this coordinate. I'm going to do the blue one because it's the most like diverse looking one. So the coordinates for this one is, see, 1, 2, 3, 4, 5, so -5. And then up 1, 2, 3. -5, 3. So the right one right here, -5, 3. This next one, 1, 2, 3, 4. So -4, -2, -4, -2. And this last one over here is all the way to 9, -9, -2, -9, -2. So if we do this reflection right, all we're going to do is just flip these numbers. So right now it's -5, 3. When we do this reflection, it becomes 3, -5. -4, -2 becomes -2. Oops, let's look at 3. -2, -4. And then reflect this one because -2, -9. Let's graph those. Let's see if it comes out right. So we're doing 3. So all these numbers should be below this line. Should be on this side of the equation. Let's look. So 3, 1, 2, 3, and then -5. 1, 2, 3, 4, 5. Okay. -2, 1, 2, -4, 1, 2, 3, 4. Oh, -2, -4. Oh, I got this one wrong. Sorry. Oh, it was looking weird. It's 3, -5, so it's +3. 1, 2, 3, -5. 1, 2, 3, 4, 5. There we go. And then -2, 1, 2, and then -4. 1, 2, 3, 4, right there. And then -2, -9, -9, right there. Still count 1, 2, 3, 4, 5, 6, 7, 8, 9, -9. And there's your shape right there. It's the exact same shape reflected. So that goes, that went right there, that went right there, and this one went way over here. Those points, exact points right there. All right, and that's your y equals x reflection. So make sure you understand this goes with this, and then this goes with the y-axis, and this goes with the x-axis. Those are the three main things we got to take from that. And then when you do just normal horizontal vertical lines, regardless of where the line's at, just count how many spaces away you are from there. The original point, how many spaces away from the line perpendicularly, you go the opposite way. So here, this was 1 unit to the left, so then you want to be 1 unit to the right, or 1 unit to the right, then you want to be 1 unit to the left. All right, y'all. Deuces.